Eminent speaker Dr. Nikhil Bugalia is a visiting assistant professor at the Department of Civil Engineering at IIT Madras. He specializes in system thinking based safety management for complex systems such as railways and construction. Immediately prior to this, he has obtained his PhD degree from the University of Tokyo in Japan, while working on safety management practices for high speed railway systems in Japan. He also holds a master's degree from the University of Tokyo and a BTech from IIT Kanpur, both in civil engineering. His interests are in organizational and regulatory factors for safe operation of infrastructure projects. A very warm welcome.
Good morning, good afternoon, good evening, everyone, depending upon where you are joining this presentation from. My name is Nikhil Bugalia, and first of all, I'm a visiting faculty here at IIT Madras in the Department of Civil Engineering. And the title of my presentation today is Safety Management of the Railway Systems. And before I begin my presentation, I would like to give a huge round of thank you for Rail Technology Expo 2021, as well as the Rail Analysis team for putting up this wonderful expo where people could talk, share their ideas. And I'm extremely humbled by this opportunity that you trusted as such young academic like me to be speaking on this particular platform. So, before I go ahead with my presentation today, I would like to give you a quick introduction. I have been working here at IIT Madras for past 7 months now as a visiting professor, but before that, I have obtained my PhD degree while working on the railway safety aspects in Japan from University of Tokyo. I also hold a master's and in civil engineering from University of Tokyo, as well as a BTech in civil engineering from IIT Kanpur. And my research topic, lies prominently on the safety management aspect of the high-speed railway, particularly working in Japan. And now I'm trying to work on Indian railway-related aspects. And unfortunately, I could not be there in person, so this is how I look. And if you have any questions, comments, doubts, and feedback, or if you are interested into working collaboratively, please feel free to reach out to this particular email address. So, okay, let's begin with the presentation today. And before that, I go into explaining what do I mean by safety. I just wanted to set up, give a picture to the audience about what kind of railway systems I imagine today. So railway systems today are getting complex. They are using new and sophisticated technology, which is this particular expo is all about. Use of software has increased. The systems have become interconnected. As you can see from the picture, which is a representational picture of the railway system I have borrowed. And technology has progressed rapidly. Railways have modernized across the world. Railways have modernized and leveraged this technology at a rapid pace. And while all of this has brought significant efficiency for managing the railway systems, there is also opposite side of it, which is the same opposite side of the same coin, you would say. On a flip side, there is a lot of, since the systems have become so complex, people who are dealing with these systems, who are being part of the system, operating with these systems, they really often do not understand how complex these systems are. And that is where sometimes when systems do not work as they were intended to work, that is where people really go blank. They do not know how to manage these systems then. And since these are so interconnected, the problems then become too difficult to contain, and the problems really rise to the levels we have never seen before. Particularly in India, we have another kind of complexity that we have created, particularly in the context of this uh, uh, Make in India program that we have, where India tried to leapfrog in bringing the latest technology from around the world and try to develop its own capacity in that. And one such example you could see is the recent Japanese high-speed railway project, where we are borrowing the state-of-the-art technology from Japan and trying to implement it in India. And we'll see how this can create challenges in the Indian context. But so far, like this is the way I see railway systems today. They have become extremely complex. And this is where I also have got an understanding during my PhD about that there is a different kind of a safety approach which is necessary while dealing with these modern day complex systems. And in my presentation today, I will walk you through about what is it, the new system safety approaches that I'm going to talk about, and how this systems thinking view on safety is contrastingly different from the traditional way of safety as we have been looking at over the past several decades now. So, first and the foremost important aspect in this is how that you, as per this latest system safety aspect, there is a necessity that we really need to move beyond the traditional failures that we can consider important for safety. So it is long held belief that it is not the components. So if all the components in the system are working correctly as how they are supposed to do, then our systems will be safe. But then, and accidents happen when these one or the other components in the system fail to do what they were originally intended to do. But the recent state-of-the-art safety theories actually show that accident not only happened because something failed to do what it was supposed to do, but in fact, modern day technologies do not fail often, or even the humans do not fail often. But the way the components interact with each other. So even when each of these components were doing exactly what they were supposed to do, accidents could still happen. And this is something which is very, very important to understand, that there is an extreme fixation about failures and safety, especially in the field of safety. And that is something which is a fundamental challenge which the modern system safety approach presents. Uh, Moving further, there's another important thing to realize, that the modern systems, or especially the railway systems, these are not technology systems, and there's a necessity that we move beyond technology as the only cure for safety. Railway systems are socio-technical in that nature. For example, there is a human which is dealing with the technology at the day-to-day level basis. This human is particularly governed by the management or the company regulations, policies under which the particular human is employed by. And these organizations themselves are then governed by the regulatory and overall business environment under which they operate on. So you could easily imagine that this is really, indeed, reality is a socio-technical system where the decisions and information flows throughout these different types of system components can actually affect the overall performance in terms of safety. For example, an organization can actually make a lot of different type of strategies in terms of how it wants to maintain a particular asset, or what level of automation they want to introduce. And all of this can have a significant impact on safety. And a recent example of it is the Boeing's AMCAS system, which was so advanced, where Boeing was expecting that it would take away the accidents, but it kind of created a complexity which really people operating the Boeing planes did not understand. And that's why it kind of created two accidents which the world has seen recently in the aviation industry. So the main message here is that we have to move beyond the technology alone. We really need to consider this socio-technical dimension for considering the safety of the future. And then we also need to move beyond focusing only on the operations phase of the systems. As you can see, operations is just one part of the system. But then there is a whole another set of components which engage in overall across system life stages. For example, there's a manufacturing component, there's a system development and system integration, system operations part is there, and then there's a maintenance evolution. And of working efficient functioning of all these life stages is very, very essential. And often there has to be a lot more focus on system design stage itself, where a lot of issues could be captured and managed, which are beyond to be managed during the operation stage. But in reality, another complexity that can be added here is that you could imagine each of these functions of manufacturing, of system integration, of maintenance, operation, these could be divided across different organizations in reality. And that is where another complexity arises, that often these organizations start working to optimize their own performances, and they end up leading to a situation where, while their own performances are optimized, they are not sharing sufficient information, or they're not passing on sufficient information to the other parts of the system. And it can also lead to certain undesirable accident related outcomes and so on. So really you need to have a thorough and holistic integrated view on system in order to really understand the safety, and also consequently the risk assessment also has to be reflective of such different life stages that are present for a given system. And one more confusion that I want that commonly is seen, at least in Indian context, is a lot of organization they tend to think that confuse the occupational safety and the process safety. While in principle there could be similar level types of controls, similar type of hierarchical systems as we saw, even to manage these occupational hazards versus process hazards. But I can give you a simplest example. For example, in this Vishakhapatnam crane incident that happened, I think in last year, do you think if the crane operator would have been wearing a PPE or the proper belt, even in that case, that accident kind of would have been avoided? No, right? And this is where you need to understand that while process safety and occupational safety are related and they could be managed using similar type of decisions, but they require different type of controls to be in place in order to manage each of these. And there is a reverse side of it also. Just because a person who was involved near the operation was not following a particular type of safety protocol related to PPE wearing or something, it does not mean that they had to have a significant contribution towards that particular accident. So you can see in this particular cartoon where clearly there is a slab which has fallen and there's a falling object which is a hazard. But the investigator ended up focusing only on what the immediate worker was doing and whether or not he or she was wearing a particular PPE or not. And this is where we need to move beyond from getting fixated on the human error elements of it. And we need to really understand how the various components within the system interact with each other, and together they lead to the complex safety related situation that we talk about. So I'll give you an example from the railway industry. This is where I have worked extensively in my PhD. And while the accident example that I will give off is from Japan, but it is very highly related to Indian context. As you can see in India also, recently we have seen a huge decline in the number of fatalities and number of accidents happening every year. And in terms of the technological comparison of the modern day system was also comparable to this accident example that I will show you in the next slide. So in this particular slide, I will demonstrate you some of the concepts that I have been talking through an example of the railway accident that happened in Japan. And this accident it happened almost 18 years ago at that time. And the particulars in terms of the technology and other things, this particular practices that are prevalent in this accident are quite similar to what are also prevalent in the current railway system in India. So let's see this particular example. So people familiar with the railway systems. They know this fixed block system of signaling and maintenance minimum distance between the trains. For example, once a train enters a particular section of the track, the electric system detects the presence and make the following signal as red. And this then, of course, the driver of the following train should not enter this particular train. So by this logic in the diagram, one could imagine that if, for example, if block A is unoccupied, the signal A would then show green. However, in this situation, what happened was there is an additional signal called this repeater signal. And the reason why this repeater signal is placed that in order to show, because the section is located at a curve, so in order to show the signal ahead, because the driver coming from this particular direction will not be able to see the signal ahead, so there is this repeater signal placed, which just mimics the exact signal aspect of the signal A that is shown here. So now in this accident, what happened is that the driver of the train A stopped in this section B. So this train A was going, and he heard a typical noise coming out of the train as if some animal or something had stuck to the particular train. So naturally the reaction was that you stop the train where you are and check. So immediately, because the train stopped in this fixed block section B, this particular aspect of signal C became the red, right? Now, there's a driver which is coming from here, and he immediately says, let's say there's a driver of train B, he immediately sees that the signal ahead is shown signal C ahead is shown red, so he immediately applies brake, which is also a natural reaction, and of course, it makes a safe practice. However, after waiting for this particular signal for about a minute, the driver then starts to proceed ahead slowly. And this is where would you think, why would it make sense for the driver to move ahead slowly, even when you see the signal is red? But let's come back to that in a minute. Before, I want to give an example of how it proceeded, how the accident proceeded. So this driver started moving at a slow speed. Here you realize this repeater signal is still showing the green aspect because practically there is no train in this fixed block section. The train is stopped here, but it has not entered the section A. So this particular signal A is still green, and that's why this mimicking signal is also green. So this particular driver coming from here sees this signal, thinks that there is no train ahead, and started to accelerate. And immediately when you start accelerating, immediately he finds that there is a train ahead, and both the train collides from the rear. Of course, there was no fatality in this particular because the speeds were low, but this gives an example of how the accidents could happen in a complicated situation such like a railway. Now let's get back to this particular thing. Why did it make sense for the driver to actually move ahead after stopping for 1 minute? And the reason is because it was the organizational rule to allow so. In this particular company, the company had made a rule that once you encounter the signal for red, you just wait for 1 minute and then proceed ahead. So it is clear that none of the components actually failed. The signal system worked exactly as we were designed to do. The humans were behaving exactly how they were told to behave, and still the accident happened. So it is not an individual component's failure. It is really the interaction of the various components that you have to understand. And you could ask that why does the organization would have such kind of rule? But to surprise to even me, actually this is quite standard policy for a lot of companies, even including Indian Railways. So in fixed block system, often there is a capacity constraint that can happen, and if trains start stopping at each train signal, of course, all the train coming behind could face a huge delay, and this delay could propagate throughout the system. So in order to minimize those kind of things, these trains they usually have this kind of rules where you are allowed to move beyond. After 1 minute, you are allowed to actually proceed at a slow speed. But the challenge was the proper risk management about this, how repeater signal, now the rules should change around the repeater signals, and several other things should have been considered properly. So this is the main message that I want to give as part of the systems thinking, that we really need to challenge the traditional view on safety that we have in India, and especially move ahead using this systems thinking aspect. So, so my main message I'm reaching almost to the end towards my presentation. My main message to here for all the railway practitioners out here is that we should really understand the modern day complexity of the full modern day railway systems. These are complexities of not only the technical in nature, but also becoming a socio-technical in nature. And there are several kind of tools. For example, an example I'm showing here is the stamp and FRAM example. And in this kind of example, through such kind of tools, you could actually map the system to a great length and realize how various system components and various system functions are actually connected. And then see, you could pan out scenarios, and you could systematically identify areas of system where the problems could happen, or where a particular function could have been skipped, or it could have been performed wrong, because of course people who are doing it are humans. They are not always efficient, they're not always reliable, they are not always performing to the par exactly as you expect them to be. And there are several other aspects in which the variability of each of these functions could occur, and then you systematically could analyze how that variability will propagate throughout the system in order to lead to an accident or not lead to an accident. So the need of the hour is for the railway practitioners, definitely I feel, is that we should understand this complexity, embrace this complexity, and learn these kind of tools. And of course, bringing back to the high-speed railway project that we are having in India. So the system safety approaches that I have described are particularly relevant for the highly complex railway project in India, which is the upcoming Mumbai-Ahmedabad high-speed railway project. And as part of the Make in India scheme, the technical know-how also has to be imported from Japan, or has to be transferred from Japan, and in form of operation manuals, etc., also need to be transferred from Japan to India. But you need to understand that the operation manuals that have been made in the Japanese exercise system are their way of prescribing how the work should happen. And of course, in any organization, there's a difference between how the people imagine the work is happening, how do they actually write the processes, how the work actually gets disclosed through the trainings, and then how work is actually done. And in between, there is a whole differences between each of these stages. And in Japan, like the idea for organization is to continuously minimize the gap between work is actually done and work is actually imagined. And in Japan, they have been able to do it over the 50 years by optimizing their works around their social technical practices. But this is where we need to understand that even if you bring exact technology from Japan to India, there's a lot of human, there's a lot of organizational practices and processes which are going to be different in India. So there is no possibility that you could simply copy paste the operation manuals that are available. And in India, we do not have that luxury. And this is where we need to systematically consider the practices, systematically analyze the work practices that we are going to bring from Japan and see whether these practices will make sense for Indian stakeholders, will it make sense for Indian conditions, and then take suitable actions to accordingly revise them. So this is the main messages that I wanted to bring forward. I just wanted to bring this new systems safety aspect that I feel is important. So safety and the particular aspect that I wanted to challenge is that safety is no longer in the realm of technology alone. You really need to consider the socio-technical aspects of the railway system, and that is where the systematic and more system safety related approaches should be used, and we should create a momentum so that the people here can understand that complexity, deal with the complexity, use the tools in order to really analyze the risk that is the level at the level which is necessary. And the second main message that I wanted to bring from my presentation is that safety really cannot be important. It cannot be imported. Organization and considering again the socio-technical element of the system, you can bring the technology, but the social aspects you have to analyze local to the system that you are dealing with. So thank you once again. Thank you for providing me with this opportunity to present my ideas, and really appreciate any question, feedback that could come through. So my email address is shown here. Thanks a lot.